Then I will speak about our mineral fibers that we produce in Belgium, what is sustainable future and an alternative to carbon and glass fibers that we commonly use in the composite manufacturing, especially in boat applications. Then I will make a short presentation of ISOMATEX, and I will explain you by 3 different examples why we use our mineral fibers reinforcement in boat applications. And then we will make a conclusion together. Then, in a few words, ISOMATEX is a Belgian company, then a European one, producing our fibers reinforcement locally. Then, what is very important to understand, what is probably the most important slide of the presentation, is that we have a unique mineral reinforcement. We don't produce glass fibers, we don't produce basalt fibers, but mineral fibers with very high performance. Of course, we come from the volcanic rock, but the volcanic rock is very variable from the origin or even from the layer of extraction. Meaning that if you keep this volcanic rock, you will have a very high variable mineralogy offering performance close to glass fibers. Here, what we do in ISOMATEX, the first things that we do is to analyze the volcanic rock that we receive, and we add 10 mineral components to always have the same mineralogy before extracting the fibers. This approach is very interesting because choosing this mineralogy, we can drastically increase the initial performances. For example, in the 10 mineral components that we had some silice to increase the mechanical performance, some alumina to increase the thermal performances, and then, for example, regarding the testing strength of the fibers, when basalt and glass have a common performances, here with our FILAVA mineral fibers, we are in the range of carbon fibers. And then we developed initially these fibers for aerospace application to increase the safety of people, mechanically and thermally. And then the name of the fibers is called FILAVA. And then we have a very high quality control, allowing us to provide some bobbins, like you see there, with a very high performance and reproducing performances. Of course, with this bobbin, we are going far from the final application, is the reason why we develop many partnerships to offer solution to our partners. From the bobbins, we can make some chopped fibers, some braiding, knitting, woven fabric, needle punch, geotextile. You can produce tape, multi-axial, it can be biaxial, triaxial, quadriaxial, UD, hybrid fabric. You can see there pictures of a fabric with flax, for example, but also some on-shell solution, like hybrid solution that you can see for the hull of the boats, for example. Then, with all this information on the fibers, your first question is why we will use it in boat application and why we will replace carbon or glass biofibers. Then I will explain you by 3 different examples. First of all is the Loop Mini 650, where the objective was to have a fully recyclable boat. Take in mind this picture because this boat doesn't exist anymore, because we fully recycle it. Then the approach is this one. We have the woven fabric used as reinforcement, that will be introduced with a bio-epoxy resin to build the boat. And then we retrieve some sample of them. First step will be to separate the resin and the fibrous reinforcement. Then, by this approach, we decided to use it to make separation by a solvolysis approach. You can do it by pyrolysis, Also, and we retrieve the fibers separate to the resin, and these fibers will come back in ISOMATEX. We will analyze its mineralogy, and then again, if the mineralogy change, we will add the mineral components to reintroduce them in our furnaces to produce fibers with exactly the same initial performances. We don't change the nature, but we adapt it to our needs. Then, always we guarantee the same mineralogy of our batch before extracting our fibers. Then from the batch that we have, we extract filament of 9 microns to produce our roving. Then we have a cradle-to-cradle approach. Just in parenthesis, this project has been managed for GS4C, what is an Italian company, and the resin that has been used has been developed by entrepreneurs. Also, we do much more than a recycle of fibers and have a cradle-to-cradle approach. We have a very high global life cycle assessment. The raw materials come from Europe. We produce in Europe because we produce in Belgium, and our partners who transform the fiber in semi-finished product are also located in Europe. If you want to weave your fibers, we can propose you some partners in Italy, for example. Also, we have an internal life cycle assessment. Since we are a very young company, we began 15 years ago in the fibers reinforcement, it's very young. It's an advantage because we introduce some way of production very modern, like for example some electromagnetic approach for the melting of our batch and the furnace of our batch. Then it means that we have a very low need of electrical energy and green energy thanks to wind turbine parks close to ISOMATEX. We produce green energy to heat our furnace. It allowing us to reduce drastically the oxy-combustions, 60% less volume of flue gas as you have in glass fibers, for example. And of course, we develop some cooling system, internal cooling system with rainwater collection recyclability, allowing us to have a very, very low CO2 emission in ISOMATEX. And of course, because we are a European company, we have to respect the REACH compliance, meaning that, of course, our fibers are 100% mineral fibers, and also we apply sizing on the fibers that are aqueous-based and respect the European legislation. And then we have the safety of our final product. Then it was the first example to show you a fully recycled boat that we produced there, allowing us to have a very low CO2 emission and a very interesting life cycle assessments for the boat manufacturing. Second one is the innovation yacht. The objective of this yacht is to make a double tour of the world, and then to be able to do it, the main objective was to have a very high shock absorption of the hull for the safety of the boat. And then how we have this solution, thanks to a very high good shock absorption of the fiber itself. In parentheses, we use also fibers for ballistic application. If we take a look on the performance of the fibers that you have here, there, we can observe that we have a tensile strength in the range of carbon fibers, but we keep an elongation at break 3 times higher than the carbon fibers, meaning that you absorb a lot of energy when you have shock absorption due to floating object orders. It's the reason why we use of fibers to have a very high reinforcement of some part of the hull, much more interesting than glass fibers, allowing you to handle very high shock, high pressure, reducing drastically the quantity of matter. Also, thanks to our approach, and thanks to the development that we made in our laboratory, we developed different kind of sizing. Sizing is the kind of coating that you apply on the fibers. This sizing allows you to have the best adhesion between the fibers and the matrix, to have, at the end, the best performance in fatigue of the final composite. If you don't use a good sizing, you will have some risk of delamination and fragile breaks. When, if you use good sizing adapted to the resin, you will have very, very high performance in fatigue of the structure. And in ISOMATEX, we develop different kind of sizing. If you want to use epoxy, we have sizing adapted to epoxy. If you want to use polyester, vinyl ester, we have different kind of sizing also. Then it's very important for ISOMATEX to be a partner of the project to provide you the best solution. And then, thanks to this performance that we have, we were able to produce a very light boat, being able to handle very high pressure, but also floating object that we have in the north of the US. Besides it, of course, because we are 100% mineral fibers, we have extremely high fire resistance. For example, we can handle temperature up to 950 degrees. We have a very high impact resistance, very high fatigue performance, thermal isolation, especially we have different projects ongoing for battery of boats, allowing to have thermal isolation, increasing the performance of the battery, but increasing the safety of the battery thanks to the impact resistance that we have. And also, we don't have any risk of galvanic corrosion, no problem with soil waters, UV, and we are really well adapted to aggressive environment like hydrocarbon. And of course, what is very interesting for this approach, again, we are fully recyclable and we have a cradle-to-cradle solution. Last one has the objective to have very high performances. When they speak about high performances, directly they thought about carbon fibers because it's very high stiffness with very low density. But, contrarily, we were able to show, thanks to this approach, to have a very high stability using the fibers, absorbing high vibration of the boat to increase, at the end, the performance of the boat. We use for this boat, we use of fibers reinforcement for the two hull, keeping carbon for the mat and for the junction. Then we use the fibers properties at the right place. And then, thanks to this intelligent approach, we drastically increase the performance of the sailor because the sailor is able to concentrate on the course and on the external aspect of it. And then, besides the recyclability, of FILAVA reinforcement is used for other reasons. First one is because it's softer and easier to handle than fiberglass, especially thanks to the sizing that we developed. We have very high mechanical properties, reducing finally the quantity and the manufacturing cost. Reducing the quantity meaning reducing the weight of the final boat to increase also the performances, but also the consumption the fuel consumption of the boat. And of course, we have a very high fire resistance characteristic for the safety of people also. And of course, we showed of FILAVA fibers with the global growing demands for circular economy. Then, thank you for your attention.